Hello and welcome to Saturday's edition of Cracking the Cryptic, and you may be able to see that I am on a new computer today, which is very exciting for me and probably quite exciting for you because you no longer have to tolerate close-up Simon anymore, which was the view that my laptop seemed to deliver. Anyway, what have we got Sudoku-wise for you? We have got this puzzle on screen, which is called A River Runs Through, because it seems to, I think these palindrome lines, for that is indeed what they are, seem to be delineating a river that's flowing through the middle of our Sudoku, and it's by a new constructor for the channel, the constructor Bees ? Now, on Logic Masters Germany, which is where this was published, it actually says that this is the first puzzle ever that Bees ? has constructed, and it has a 99% approval rating and is of average difficulty, so a quite extraordinary debut if indeed it is their first puzzle ever. So I'll read the rules in just a second. Just a quick appeal first. Do check out what we've got going on over on Patreon. We've got Mark's most recent solve of a vicious cryptic crossword. We've got DiMono's Everything Wrogn is on Fire, his sequel Sudoku to Everything Is Wrogn, and we're going to release the solution video to that in just a few days' time. So if you are struggling to see what was going on, and if you are, I wouldn't blame you, that puzzle is very, very hard, then that solution video will be coming your way very soon. Now, let's read the rules of Bees ? But I'm not sure whether I meant to say Bees ? each time, by the way. The pseudonym on Logic Masters Germany was indeed Bees ? spelt out. So it could be that I am meant to. Anyway, what are the rules? Normal Sudoku rules apply. Cells with grey circles must contain odd digits. Cells with grey squares must contain even digits. In cages, digits must sum to the small clue in the top left corner of the cage. There's only one cage, and indeed, rather unusually on Cracking the Cryptic, that is an immediately useful cage because I can write in the candidates for it. Clues outside the grid give the sum of the cells along the indicated diagonal, and digits can repeat along these diagonals. So you can see, for example, those squares there, 7 squares have to add up to 47, and you can repeat a digit. So, you know, if you make that an 8, it's absolutely fine for that square to be an 8. What's not fine is for you then to put an 8 there, because those are in the same box. Don't do that. That will break the rules of Sudoku. But you can certainly repeat numbers on a diagonal, providing it doesn't break the other rules of the puzzle. And the grey lines are palindromes, i.e. the string of digits on the line must read the same forwards and backwards. So you can see we've got 2 river banks here being the palindromes. So if we discovered that those cells were 1, 2 and 3, we would know immediately that those cells must be 1, 2 and 3 in the other order. So that as we read the string of digits in this direction, it would read 1, 2, 3. And as we read it in this direction, it reads the same, 1, 2, 3. So we have to make sure that our palindrome is sort of symmetrical. And in fact, look, so this must be a 13 cell palindrome. It therefore has a center, this square here, and this is the only cell on the palindrome that doesn't have a twin. So that's how the rules work. Do have a go at the puzzle. The way to play is to click the link under the video as usual. Now I get to play. Let's get cracking. And I think I'm going to start by immediately penciling in 6, 7, 8, 9 in the 30 cage, because it's nice to do something straight away. And in fact, there is a 6 diagonal there that must be 1, 2 and 3. Now probably the gifts run dry there by the looks of things, but that still feels amazing. Right, actually I'm noticing something about this palindrome, the top palindrome, straight away, because this domino here is interesting. Because that domino, the equivalent of this domino on the palindrome is that domino. So whatever goes in this square also goes in this square. I'll just colour them in. Whatever goes in that square goes in that square. So what can we put in purple and green, therefore? Well, look at the effect on box 5. whatever goes in purple cannot go in those squares, so must live in the 30 cage. Same thing is true of green. So these squares here have got to be from 6, 7, 8 and 9. We may, yes, we can do the same thing on the other palindrome, those squares. These two squares, whatever goes into those squares is the same digit because of the palindrome property, therefore is not there, therefore is in those squares. I probably should colour them in. I know I should colour them in. I will, don't worry. We'll put those in blue. Now, can we use that to our advantage? 2, 1, 2, 3. Yeah, oh, good grief. Yes, we can. We can get all 7 digits of this palindrome straight away. Look, those squares there have to add up to 22, but these 3 squares cannot add up to less than 18 because the minimum I could make them individually would be 6. But it's a 7-cell palindrome, so if I make those add up to 18, how can I fill the remaining 4 squares without breaking the 22 barrier? The answer is only with one way. They must all be 1, these must all be 6, and we are cooking with gas. We can get rid of 6 from green. We can get rid of 6s from the central 2 by 2. And now we can get rid of 6s from blue. And we can, what else can we do? We've got a 1 on a 17 diagonal now. Those squares have got to be 7 and 9. It's the only way of making 16 with 2 cells if you can't repeat the 8. And you can't repeat an 8 in the same box of a Sudoku. There is a knowledge bomb. The 7, 9 must reflect up there. So are we building up knowledge about this diagonal, therefore? Not so much, to be honest, because this is a 7-cell diagonal adding to 47, so each digit, well, the average digit is close to 7, so we would expect this palindrome to contain quite a few high numbers. 1. There's 4. Wherever you have the same digit pointing 4 times at a box of a Sudoku, you can always write that number in. That's a 1. Yeah, keep going. 1s. Where does 1 go on the 6 diagonal? Only there. There's a weird symmetry about these positions, isn't there? The palindrome creates... It's almost symmetrical, what's going on there to what's going on here, albeit that it's created by a diagonal palindrome. 1 has to be in one of those 2 cells, one of these 2 squares. So 1's either on the palindrome there, not on the 47 diagonal though, that would have been useful. Oh, it's beautiful. Absolutely beautiful. Right, 1's, let's keep looking at those. If the 1 is on the palindrome, everything is fine with the world. If the 1 is not on the palindrome, if the 1 is here, you can't put the 1 in box 8 in this square, because then obviously that square has to be a 1. So there's sort of 2 possibilities for the 1's. They're either in these 2 squares or they're in those 2 squares. Well, they're not in these 2 squares, because if they're in those 2 squares, you can't put a 1 in those 2 squares, and that would imply that 1 was the same as a 6, 7, 8 or 9. Well, it's not. So those are not 1. 1 must live in these squares, I think. And therefore we've got the same thing going on in box 5 that we had over in box 3. 1 is looking into this box from 4 different places, so that square is a 1. And that 1 is on the 47 diagonal. I love this puzzle so far. It's just beautiful without being too difficult. Right, something I can see from the 1 being here is we can immediately use the sort of parity implied by the palindrome line, because we know that the whole of this diagonal sums to 47. lop 1 off, 46. Well, we know those 3 squares have to add up to exactly the same as those 3 squares, because they must be the same digits. So those must add up to half of 46, which is 23. And so if that is 7, can we still make that work? Yes, we can. If that's 7, those squares will have to add up to 16, which will have to be 7 and 9, which would make that square an 8. And if that's 9, these have to add up to 14, which could be done either way. Oh, okay, so maybe this is not what we're meant to do. That's quite surprising though. This one felt very beautiful, didn't it? Let's check the rest of this. If we've got digits in these 2 squares, no, that doesn't look interesting. Those 2 squares. Ah, yes. Look at this. Running out of colours. These, whatever is in orange, if this was 7, 8 or 9, you couldn't put 7, 8 or 9 in the 30 cage anymore. So these are not 7, 8 or 9. So these have a highest value of 6, I think. Yeah, so just to be clear about that, if you try and put 7 into those squares, look, you can't put 7 into any of those positions. So this has to be, that's going to put pressure on the wings, I think, because now, if these can't be higher than 6, we've got to get this to equal 23. So if this is 6, these have to add to 17. So that would have to be 9 and 8. If this is 5, yeah, this is lovely. If this is 5, these have to add up to 18, which means they have to be double 9. So this square is always 8 or 9. Therefore, that square is always 8 or 9. But more importantly, that square is never 7. That is always 9, which means that square's always 9. 9's in one of those 3 squares. This square is a 5 or a 6 as well as its friend in the orange. Let's colour those 2 in so that we remember that they're the same as well. What should I make those? No, I can't make them grey. I can't make them grey. I'm going to think they have to be even. I will make them red. I've still got red available. There we go. So red. Right, this is nice. Whatever red is, we know it must live in those 4 squares in the central box. Well, if this was double 9, that would rule 9 out of those squares and put it here. Same thing is obviously true for 8. So that square is red and it's not 7. Now, no, I was about to put red in here, but red could be green. The things I say on Cracking the Cryptic. Yeah, I don't think we know. There's a chance red is equal to green. It probably is equal to green, actually. It looks very symmetrical. Right, okay, so we can't do that. What does that mean? It means that we've got to look harder for other things. We can, what can we do? We can... I don't know what we're meant to do next. It must be... I really don't know. Sorry, let me just try and find something that's useful. We can... These 2 squares, are they useful? I'm not sure that they are. 9's in one of 3 positions in box 3 by Sudoku using these 9's. Okay, I'm really getting stuck, I think. We can... Oh, that's a 7. Let's just use the 17 diagonal, which we've already resolved. Sorry. So that square now is a bit more restricted than it used to be. It can't be 1, 3 or 7, but we know it's odd. That's 5. Oops, this square here is 5 or 9. That's beautiful. That really is lovely. This 7, I was about to demean it and sort of say it's a pretty useless 7 in an effort to hide my embarrassment for not spotting that it was there immediately. But this 7 would have been unfairly maligned had I done that, because this 7 actually, by inflicting itself on this square, it has disambiguated this diagonal, because once this can only be 5 or 9, this square cannot be 5, because we know those two squares are adding to 14. So 5 and 9 makes red 9, and we'd have a 5-9 pair here looking at this square. So this 7 actually is a kingmaker. This square therefore cannot be 5, this is 6, this is 8, and we are off and running again. That means red is 8 in the middle, so we've got these down to being 7 or 9. We still don't know about greens and reds, I don't think. But we do know what blue is now, because there is a funny... It's almost an empty rectangle, a sort of classic Sudoku technique going on in box 7 here. The 9s are either... that we can view this pattern of 9s as sort of a binary state. The 9s are either in column 3 or they're in row 7. Or obviously they're in this square and they're both. But it doesn't matter in this instance. If the 9s are in row 7, blue is not 9. Therefore that's not 9. If they're in column 3, this isn't 9, therefore this isn't 9. So wherever the 9 goes in box 7, it's always eliminating itself from blue, and therefore blue is 7. And that doesn't seem to get anything done in the middle box. Plonks 7 in one of 2 places down in box 7 there. And removes it from green now. That still doesn't tell us whether green is red. Oh, this is sensationally good though. The 9 pencil marks in box 3 do the same trick again. It's the same trick. 9 is either in row 1 or it's in column 9. Either way, it's ruling itself out from green. So green is 8 and green is... Yep, green is red. Things we can prove with the power of Sudoku. So now do we know... we know a little bit about red in box 3, because red is 8 and 8 is not an odd number. So 8 is in one of 2 places. 8 is in one of 2 places there. Whoopsie. Let me just have a look at... see if we can do anything else with 8. We can get 8 into one of 2 places in box 7. We can... now what can we do? We can... I'm not sure what we can do. Hang on a sec. We can... What digits do we know a lot about? We know a little bit about 6s. I've got 6s in 2 different colours though now. That's a bit silly. Let's change 6s to orange. So 6 has got to be in one of 3 positions in box 1. and one of 3 positions in box 9. Again, that's a weird... It's weird the way the symmetry is working there. It's sort of the position... The pencil marks for 6s are sort of a reflection and rotation in boxes 1 and 9. Oh, 6 there, look. Ah, yeah, hang on. Look at 6 in box 7. It can't... 6 is not odd, so 6 is in one of 2 places, which means 6 is not here. That's lovely. Now my 6s and 8s in box 1 are not in the grey squares, but the grey squares are even. So that's a 2-4 pair. That C's down here a 2-3 pair. So where does 2 go in column 2 of the grid? Not here. Not there. It must be in one of those 2 squares. Now, what have I not used so far? I've not... I feel like I've used most of the clues, but I can't have done. I've used the 22. I've not used all of the palindrome, I suppose. Maybe I've got to think about that. So if these squares... Yeah, okay, these yellow squares here can't be 7 or 9. Oh, you can see they can't be 7. There's a 7 in here, but they can't be 9 either. They would rule 9 out of the 2x2 in the central box. So these squares have to be 2, 3, 4 or 5. Oh, whoopsie, sorry, I didn't mean to do that. Just those squares have to be 2, 3, 4 or 5, because they can't be 1, 6, 7, 8 or 9. But that doesn't seem to be restricted at all. What am I missing here? Sorry, I'm not intending to be slow, I promise. Is it 8s here? No, 8s have got a similar sort of pencil marking pattern to 6s, but is it the same there? Not quite. Oh, it's because these 8s disambiguated something because of the circles here. There's some strange stuff going on. 7s. Ah, if in doubt, let Sudoku be your friend. Where does 9 go in column 4 of the grid? 9 is not in those 2 squares because we know that 9 is in one of these 2. 9 isn't there, there's a 9. 9 isn't here, there's a 9. 9 is in one place, it's there. Oh, now that's nice, that gets me a 5. That locks a 5 out of that one, which locks a 5 out of that one. 9. So now, what's that done for me? Has it done anything? Doesn't seem to have done as much as I was hoping, if I'm honest. What's this one then now? This is odd, and it's not 1, 5, it's not 9. This is 3 or 7. I think that's still possible though. 2, 3, 4 there. No, I still don't know where the 7s and the 9s go in box 5. Ah, I'm stuck. 9. Oh, I see. It's symmetry again. Look, the 9 is restricted in column 4, but the sort of equivalent of column 4 created by the palindromic rivers is row 6. And where does the 9 go in row 6? It's not there because of the 7-9 pair. It's not here, there's a 9. It's not there because of the 9. 9 is there. And that means that squares... Oh, that means lots of things. That means lots of things. We knew one of these 2 squares is a 2. It's now that one, which places 2 on the palindrome. Oh, it doesn't resolve where 2 goes in box 7, but this 9 does resolve where 9 goes. 9 goes there, which means 8 goes here, and 7 goes here, if I trust my pencil marks. Why wouldn't I do that? No, I think I can. Yeah, that looks good. So now 6 must go here. This whole box has just been finished in a trice. That is good news. 8 is not there anymore. This column is all but done. We need 3s, 5s and 6s into the top. That's not a 6. Those 2 squares must be 7 and 8, which we can place. Good. 7 and 8 go in. This square's a 3 or a 4 because we've got a 2, 3, 4 triple unplaced in the column. These squares are 3, 4 or 5 in some order. We know there's a 5 in one of them. Now let's come back down here because we did a lot of stuff there really quickly. And I just want to make sure I'm not missing any of the implications. 6, yeah, oh yeah, 6 is in the corner. Those 2 squares have got to be 3 and 4 just by Sudoku. These squares have got to be 2, 5 and 8. Let's put that in and have a look at it. I can see that's not 8. That square's got to be 3 or 5 because it can't be 2 or 8. This square is most certainly even, so that can't be 5. So 5 is in one of those 2 squares, which means... I don't know what it means. 4 is in one of these 2 squares. And... okay. Now we pause for breath again and see what we can spot. So 8s, 6s. 6 is a little bit restricted. 6 is in one of those 2 positions. These squares, what are they? If these squares here are 7 or 9, we have the same problem that we would have had with these being 7 or 9. You can't make those 7 or 9. It would rule 7 or 9 out of both of those. The same is true, look, of those 2 squares. These squares here can only be 2, 3, 4 or 5. This one can't be 5 because it sees 5 in its column. Or 2, it sees 2 in its row. That one is a 3 or a 4, so that one is a 3 or a 4. No, it's still not. It's still not yielding, is it? 7. Oh, 7 is a bit restricted in this box. These 7s are locking a 7 into one of 2 places. Oh, that's nice. Yeah, okay. Where does 7 go in box 3? It's got to go in those 2 squares there, where it's joining a 6. So there's a 6-7 pair, which means this is not 8, which means 8 is here. Therefore, 8 is here, I think. Okay. Is that helpful? It might be. It is helpful. Look, 7 is restricted in this box as well. These 2 7s are operating to lock a 7 into one of those 2 squares, which resolves the 6 and the 7 here. That's lovely with the 11 diagonal. That's now got to be a 4. That 4 sees a 4 and a 3 in the column. This 4 sees the 2 and the 4 in box... Oh, this is lovely now. It's just... We're tripping the light. Fantastic, aren't we? We've got 2, 3 here. 2, 5 here. 3 going in here. This square, which is on the palindrome, is not 4. So that's not 4. And 2, it's not 2 either. Now we've got a 3, 5 pair. We've got a 4, 5 pair here, which I can't do. We've got, what else have we got? We've got a buzzing phone. We've got, oh no, we can't quite limit these down, can we? What's the options for this one? We've got 3 or 5. Ah, yes, we can. 3 or 5 for this square, because it sees 1, 7 and 9. Well, 3 and 5 is beautiful. There's a 3-5 pair in the row, so that's a 4, which means that's a 4 by the palindrome. 4 goes here by the power of Sudoku. Actually, the 4 and 5 down there are fixed. 5 is in one of these squares. 5 is in, we don't know that yet. This column, look, hasn't got a 2 in it. So we can place the 2. This box hasn't got a 2 in it. Where's it going to go? It's got to go there. That gives us the 3. The 3 and the 5 get fixed. This row needs to have 7 or a 9 in this position. No, can't do it. Oh, come on. This is 2, 9 missing from this row. Let's put that in. Oh, that's still not done either. Oh, this column, look, sorry, that's got to be a 3. So that's a 5, that's a 6. And that means this square is a, well, I've got a 3-5 pair here. Maybe this one then? So this has got to be 3, 5 or 9. It can't be 5. So it's 3 or 9. So this is 3 or no, that's still okay as well. What a clue have I not used? Oh, look, it's this diagonal. It's the palindrome. The 5 here gives me a 5 here. And I'm presuming, yes, that gives me the 3 here. That gives me the 9 here. It's lovely, isn't it? That's a 3 now. The 3 and the 5 are done over there. 9 can only go here. 2 can only go here. These are a 7-9 pair. That looks like it's going to have to be resolved by this at the top. Yeah, where does 2 go in this box? It's got to be like that. Finally, this quadruple, which is the place I started, gets resolved, which is right at the very end, I think, of the puzzle. And that should be a 5. And that is, I think, the correct solution. Wonderful. Absolutely wonderful. I hope you enjoyed that puzzle. I really hope you had a go at it. It's a brilliant, brilliant construction from B's question mark, and I loved it. And we'll be back later with another edition of Cracking the Cryptic.